Welcome back to our data science and assignment video series. This is the second part of part C. So here we'll continue with the leftover questions. So let's dive deep into it. Part C, data preprocessing for feedback analytics. Okay, so question number 14 says that normalize the following faculty workload values R per semester. Here we are given the value 200, 300, 400, 600 and 1000 using A and D, which are methods, A to D methods, all the methods. So let's solve by each method. We'll take the given data. Now preliminary calculations are minimum is 200, maximum is 1000, mean is 500 and the range is 800. So standard deviation, so deviation is, we'll calculate and we'll get the values squared, well, then we'll square it. We'll take out the variance is equals to this and rho is equals to 1316.23. Variance equals to 1 lakh. Okay, so method A is min-max normalization, which range from 0 to 1. So formula is equals to x minus min upon max minus min. So we'll calculate origin calculation and we'll call the normalized one also. So result we'll get is 0.000, 0.125, 0.250, 0.500, 1.000. We'll use second method, which is z-score normalization. So here sigma is equals to 12.94. So wait, the question says that sigma is 12.94, but this seems incorrect for this data set. Let me use the given value as instructed. So we'll calculate the formula using sigma 12.94. So is the table. Here origins are mentioned, calculation and normalized value also. So the results are minus 23.19, minus 15.46, minus 7.73, 7.73 and 38.64. Note these values seem unusual because sigma is 12.94 appears to be smaller for this data. If we use the correct one, sigma is equals to 316.23, then the values would have been different, which is mentioned below. Okay. Next is method C, which is decimal scaling. Formula is this. So we'll find J such that max is smaller than 1. 1 is smaller than max. Okay. Max value is 1000. Need 1000. Need 10J to be greater than 1000. And J is equals to 4 since 10 to the 4. So 1000 is greater than 1000. Origin calculation and normalized. We have a table over here. We'll see in it. So the result are 0.02, 0.03, 0.04, 0.06 and 0.10. Now we'll go on to the method D, which is which method is most appropriate and why. So min-max method, clear 0 to 1 range, easily interpreted, preserves relative distances. 1000 outliers sets the upper bound, compresses outer values. Z-score method, with given sigma, it produces unrealistic value. If correct sigma is used, would show 1000 is clear outlier and z equals to 1.58. Now good for statistical analysis. Decimal scaling method C is simple, preserves magnitude. All values clustered near 0, poor discrimination, doesn't equalize variance. So when to use which alternative method? You're comparing across semester with different max values, use z-score. If identifying statistical outlier, use z-score. If 1000 R is an error outlier, do Robert scaling and remove outlier first. So next question is question number 15. Using the feedback rating data sets, normalize the value 35 using min-max normalization, z-score, decimal, and discuss which method is most appropriate and why. Okay, so we have context. Data sets are given. Min is 13, max is 17, mean is 30.15 and variance sigma is equals to 16.08. We'll take out min-max normalization, so it is 0.386. Interpretation is rating is 35. The rating of 35 is 38.6% of the way between the minimum and maximum ratings. Method B is z-score, where sigma is 12.94. The question specifies the sigma is 12.94, though this seen to be different context. So using this, we'll calculate the value and we'll get 0.375. and using the correct one we'll calculate, so we'll get the value 0.302. Next, interpretation. Rating of 35 is about 0.3 standard deviation above the mean, slightly above average. Method C is decimal scaling. So formula here is x is equals to x by 10, this for our data range 13 to 70. So max is equals to 70. We'll need 10j should also be greater than 70. J equals to 2. So x bar 35 upon 100. So x bar is 0.35. Now interpretation, simple scaling by factor 100. Simple scaling by factor of 100. The method D is which method is most appropriate and why. So comparison of 35. Min max will result, this is the given result. Interpretation is 38.6 through range. Z score above mean. Decimal is raw value by 100. Next question is question number 16. Using age as productivity data from question 4, normalize both attributes using Z-score normalization. Compute person correlation, coefficient and covariance. Comment on whether the relationship is positive or negative. So we have given the data age equals to 23, 23, 27, 27 and so on. And also given the percentage means productivity. So first of all you have to take out normalize both attributes using Z-score. So for age, mean is 46.44 and variance is 13.22. So the normalized ages are given as this on this table. We'll see original, calculation and normalized one. And for productivity, mean is 28.78%. Variance is 9.25. So normalized productivity, we'll see it in the table. Here original, calculated and normalized one are given. Now part B is compute person's correlation, coefficient and covariance. Comment on whether relationship is positive or negative. So formula for person's RR will calculate with normalized data. This simplifies this and the table is shown below. Here we have age, product X and products. Okay. Sum of product is 13.89. Persons R is equals to 13.89 upon 17, which is equals to 0.817. Curve means age productivity is given as this, and using original curve will get 100. Now question number 17. Suppose students project evaluation scores are this. Partition into bin using square frequent partition, equal with partition, cherry string. Okay. So we need to partition this into bins using 3 different methods. First is equal frequency partition. So goal is to each bin has approximate the same number of observation. Given 12 values, let's create 3 bins for 4 value each. So bin will calculate 5, 10, 11, 13. So range is 5 to 13. We'll count from 4. Bin 2 is 15, 35, 50, 55. Range is 15 to 55. Count is 4. Next bin is bin 3, 72, 92, 204, 215. Range is 72 to 215. Count 4. Characteristics are equal counts for each. Very different bin width. Jo bin width it is so much different. And last bin has huge range 143 versus first bin 8. Okay. Method B is equal with partition. Each bin has the same width. Range is maximum 215 to 5, 210 for 3 bins. And width is 210 by 3, it's also 70. So first bin is 5 and 75. Values are given. Count is 9. Second bin is 75 and 145. So the count is 92. Value is 92 and count is 1. Bin 3 is 145 to 215. The value is 204 and 215. And count is 2. Characteristics are it is equal in width 70 each. Very balanced count 9, 1, 2, 9, 1 and 2. Middle bin almost empty. Okay. Now we have method C, clustering. So goal is to group similar values together using distance based clustering, k mean or with k is equals to 3. Looking at the natural gap in data, gap 1 between 1530, difference is 20. Gap 2 is 55 to 72, difference is 17. Gap 3 is 90, between 92 and 204, the difference is 112, which is largest gap. Cluster 1 is low score. So we have centroid is 10.8, range is 5 to 15, count is 5. Cluster 2 is medium score. Here centroid is 60.8, Range is 35 to 92. Count is 5. Cluster 3 is high score. Range is centroid is 209.5. Range is 204 to 215. Count is 2. Characteristics are it group similar scores. Respect natural gaps. Unreal counts are 5, 5 and 2. More meaningful categories fade low, pass medium and excellent high. We'll move on to the next question. It says that use a flowchart to summarize attribute selection techniques for feedback analysis. Okay, so forward selection, backward selection and hybrid method. So attribute selection flowchart. Okay, here it is given the flowchart. So the three main methods are filter method. This evaluates features before training. Common techniques are chi-square. It is test independent, categorical. Correlation, remove high correlate feature. Information gain is entropy reduction. Variance is threshold, remove low variance features. Example of feedback are calculate correlation between all rating attributes, remove features with correlation which is greater than 0.95, keep top 10 features by information gain. Pros are it is fast and model agonist, and cons are ignores feature interaction. No wrappers method. Use machine learning model to evaluate feature subsets. Techniques involve forward selection, start, add best features, faculty rating, add next, faculty rating, content quality, continue until it improve. Until no improvement. Okay. Now backward elimination. Start with all feature, remove worst and continue. And third is recursion feature. Eliminate REF. Training model, rank feature, improve worst and repeat. Pros are it consider interaction optimized for model, and cons are slow and risk of overfitting. Third one is embedded method. It process feature selection during model. Techniques are lasso L1, string coefficient to 0 automatic selection. For random forest are feature independent score, content quality 0.35, faculty response is 0.28. Infrastructure is 0.12. Remove low importance feature. Pros are faster than wrapper, consider interactions. Cons are it is model specific. Okay, this is decision guide. How many features and how to use it. Use filter, wrapper, then embedded or embedded. So with this we come to the end of the video. So here the part C ends. In next video we'll cover part D. So thanks for watching.